For decades, American air power rested on a simple idea: build vast fixed bases, lay down long runways, and launch the most advanced jets on Earth. That worked when enemies couldn't reach those bases. But in the age of precision missiles and swarming drones, concrete is starting to look like a liability. A single well-aimed strike can shut down an airfield before a single sortie lifts off. Meanwhile, new technologies, hybrid electric propulsion, compact nuclear power, drone swarms, and directed energy defenses are making a once-impossible idea feasible. The land carrier, a mobile, self-sustaining launch hub that refuses to stay put. The hypersonic threat to fixed runways. China has spent years building weapons to cripple U.S. air power from day one of a conflict. The DF-17 hypersonic glide vehicle travels 1,800 to 2,500 kilometers at speeds between Mach 5 and Mach 10, slamming into targets at nearly 3 kilometers per second. The DF-21D, dubbed the Carrier Killer, has a range of about 1,450 kilometers and can maneuver in its final moments to avoid defenses. The longer-range DF-26 reaches 2,500 to 5,000 kilometers, with accuracy tight enough to destroy runways or disable large ships. Each missile costs roughly $10 to $15 million, pocket change compared to the hundreds of millions the United States spends hardening and repairing airfields. Russia has its own arsenal. The 3M-22 Zircon cruise missile flies at roughly Mach 9 over 1,000 kilometers and is difficult to intercept. The avant-garde hypersonic glide vehicle is even faster, Mach 20 to 27, delivering impact energy equal to tens of tons of TNT. Moscow also combines missiles with electronic warfare that blinds radars and jams communications, while swarms of cheap drones loiter above repair crews. The war in Ukraine has already previewed this approach. Iskander missiles shatter runways, glide bombs slip through air defenses, and drones force engineers to abandon repairs. Every strike costs the attacker millions, but forces the defender to spend exponentially more. A cost war the US is losing. Each DF-17 may cost China $15 million. Repairing one US runway after a precision strike can exceed $100 million once procurement and contractor overhead are factored in. Meanwhile, advanced stealth fighters sit idle if their airfield is cratered. America keeps pouring billions into hardened shelters and new pavement, but those fixed assets remain easy, pre-programmed targets. Even nature conspires against runways. Desert heat buckles pavement, Arctic frost fractures concrete, and dust can clog jet engines. Without enemy fire, runways demand constant maintenance. Under missile attack, they are simply untenable. In a war where the opening day may decide everything, clinging to fixed infrastructure looks increasingly like a losing bet, from abandoned dream to viable strategy. The idea of a massive land-based air platform isn't new. Military thinkers in the early 20th century sketched land battleships and mobile airfields. They failed because engines lacked power, suspensions collapsed under weight, fuel use was astronomical, and vehicles bogged down in mud. The dream was inspiring but unbuildable. Technology has caught up. NASA's crawler transporters, which carry rockets at Cape Canaveral, already prove that vehicles weighing thousands of tons can move on tracks. They are slow and diesel-hungry, but show the art of ultra-heavy mobility. Today, hybrid electric drives can spread torque efficiently, advanced materials lower ground pressure, and digital control systems plan unpredictable routes. Compact nuclear microreactors, under development in Pentagon projects like Project Pele, could generate megawatts of energy without endless fuel convoys. Directed energy defenses and electronic warfare have matured enough to ride along. What was once fantasy is now technically achievable. Anatomy of a desert carrier. Picture a hull wider than a football field, riding on modular tracked bogies, each with its own suspension and electric motor. Weight spreads out so the ground pressure matches a heavy tank, letting a 20,000-ton platform roll across sand or dirt without sinking. Speed isn't the goal. Survival is. Moving 20 to 40 kilometers every few hours would be enough to dodge precision targeting and frustrate missile planners. Power unlocks the design. Diesel alone would choke it in fuel convoys, but a hybrid electric system, efficient generators feeding batteries and fuel cells, makes sense today. Soon, 1 to 5 megawatt microreactors could deliver nearly continuous electricity for propulsion, sensors, communications, drone charging, and high-energy weapons. Independence from fuel supply lines turns the concept from fragile to feasible. On deck, the carrier would not house traditional stealth jets, but swarms of unmanned aircraft. 6 vertical takeoff pads could launch combat drones, while 2 tilt rotor spots handle resupply. Below, dust-sealed hangars store racks of drones, munitions, and batteries, safe from heat and grit. The air wing would emphasize mass and endurance. Long-range strike scouts like the XQ-58 Valkyrie could reach deep into contested space. Medium-endurance drones could patrol for more than a day, keeping watch and feeding targeting data. Loitering munitions could circle ahead of the carrier, ready to strike at armor or missile batteries. Tilt rotorcraft could keep the fleet supplied. Sensors would be equally advanced. A mix of active radars, infrared domes, and passive radio listening posts would feed a digital battle network, linking every drone and defensive weapon. Decoy emitters and false heat trails could confuse satellites and long-range sensors, making it appear as though several vehicles were scattered across terrain instead of one. Defense would come in layers. Electronic warfare could jam seekers and scramble targeting. Close-in weapon systems firing thousands of rounds per minute could shred threats at short range. High-energy lasers, already tested at 100 to 300 kilowatts, could burn drones or incoming rounds within seconds at negligible cost per shot. The goal isn't invincibility, but forcing the enemy to spend fortunes for little result. Tempo, the true advantage. A land carrier's edge isn't just survival, it's relentless tempo. 6 drone pads launching every 15 minutes could fly 200-plus intelligence, strike, or electronic warfare sorties a day. Medium-endurance drones keep a constant picture of the fight. Loitering munitions hold a forward threat. Every 4 to 6 hours, the carrier can shift 20 to 40 kilometers, leaving decoys and false signatures. Moves take under an hour while overhead drones maintain coverage, so the rhythm never stops. It could stay active 20-plus hours a day while disrupting enemy targeting cycles. The economics of survival. The cost exchange heavily favors the defender once mobility is added. Chinese DF-17 or DF-26 missiles cost millions per shot. Russian hypersonics and cruise weapons run into the high 6 or low 7 figures. Repairing a runway can exceed $100 million. A land carrier's defense costs far less. A laser shot is pennies of electricity, a burst from a close-in gun runs only a few $1,000s, and a loitering drone strike on an enemy launcher might cost hundreds of thousands, not millions. Lasers don't run out of ammo as long as power is available, and guns or drones can be reloaded while the vehicle moves. Instead of draining budgets to survive, the defender flips the cost curve, forcing the attacker to waste expensive missiles on a target that rarely stays put. Rethinking air power before the first day. For decades, the Pentagon has poured billions into fixed assets, massive carriers, stealth bombers, and sprawling bases. But in an age of hypersonic missiles and cheap drones, these can be crippled in the first strike. A dispersed mobile model flips the script. If runways move, they can't be pre-targeted. If swarms of affordable autonomous aircraft replace a few exquisite crewed jets, air power can keep fighting. If defenses cost pennies per kill, the cost equation reverses. Nature favors mobility too. Harsh climates matter less when airfields move instead of being endlessly repaired. The technologies, electric drives, compact reactors, high-energy lasers, autonomous drones, digital command networks already exist. What's missing is integration and the will to fund it. Mobility as the new armor. Hypersonic weapons, electronic warfare, and drone swarms make fixed runways obsolete. Mobility itself becomes protection. A land carrier that relocates, hides, and launches non-stop sorties would keep air power alive under massive attack, forcing enemies to waste fortunes striking empty ground. The first day of war could decide its outcome. To win it, America must unshackle air power from fixed bases and invest in mobile, resilient land carriers that can move, adapt, and endure. And that's the battlefield math the Pentagon can't ignore. If you found this video eye-opening, hit that like and subscribe, and turn on the bell so you don't miss the next upload. Thanks for watching, and remember, mobility is armor.